Gonna be a day. Alrighty. Let's go ahead and in our calculator, if you would like, go ahead and graph that in our calculator. So to do that, I'm going to go to my y equals. I'm going to put in my parentheses, x minus 2 squared, and then what? Plus 3? So that's what my calculator looks like. You can look at it and not the squint. X is right there. It'll work. And I'm going to graph. Still right there. Literally on your paper, Alicia. Alright, so we got that. Can you go ahead and copy down that picture on your notes, please? What that looks like? Okay, what were our transformations? What happened? I moved over, going right 2, and then what else? 3. Just get the general shape of it. You don't have to get every single point. Just a general shape. All right, and then it says highlight. So using that other color that I asked you to get out, highlight the part of the function where x is less than or equal to 1. So highlight here. X is less than or equal to 1. So here's my 1. So x is less than or equal to 1. That part right there. Now, as long as you drew your picture fairly accurate, where is my endpoint, in quotations there, of my highlighted part? Now, where does it start? 1, 4. Okay, so we're just talking about the yellow part on here, or your highlighted part in red, or whatever color you're using. If I were to say in interval notation, so it's using brackets and parentheses, if we're just talking about the yellow part, what would the domain be? Negative infinity to
positive infinity.
Okay, we're just talking about the yellow part. Someone said it. 1. Good job. To 1. Well done. We're just talking about the yellow part. We're pretending that the black part on my screen is not there anymore. We're just there. What about the range? The lowest to the highest.
Positive to yeah.
Okay, hold on. What's the y value? The lowest y value? 4, right? And the highest value is infinity, so 4 to infinity. That's essentially what we're doing today. Can you take your headphone out, please? That's essentially what we're doing. We're breaking a piece of a graph off and just talking about that certain piece. That's why the whole entire lesson is called Piecewise. We're breaking stuff up. So that definition there is a function that is a combination of 1 or 2 functions. We're combining stuff together. All right, so let's go ahead and knock out an example. The format of piecewise functions, that's what this is going to look like right here. So everything is always going to be this f of x equals and then a big, huge bracket. And for like example number 1, we have 2 different pieces that will be graphing. Now the first part, how we read this is we're saying x squared, and then only for x is smaller than -2. So if I were to fill out my table here, I'm going to stop at 2 right here. Okay, so let's go ahead and plug in our numbers here. So what is -3 squared?
-3 squared
Is 9, right? What about -2 squared?
4.
4. -1 squared?
1.
Yeah. Cool. And then stop at 2. And then it says, awesome, good job. Now I'm going to use this other function for everything bigger than 2. So I'm putting 2 pieces together. I'm done with this puzzle piece, now I'm going to this one. So for everything bigger than 2, x would be just that number, right? So if I plug in 3 into x, what's my y value? 3, 4, 5, 6, 7. It's like graphing the entire y equals x squared, graphing the entire y equals x, but then we're cutting part of it off, and we're cutting the other part of it off. Last one we should probably do, or the first one we should probably done is 2. For this one, I'll show you why here in a moment. All right, the first thing, let's go ahead and graph these ordered pairs for x squared. So I'm starting at -3. I'm at 9. Way up here. -2, I'm at 4. And you can questions? Other than what the heck are we doing? All right, now it says for everything smaller than 2, right? So I'm going to go ahead and put an arrow at the end here because it's everything smaller than 2, and we know parabolas keep on going both ways. In this case, we're just going on the left. The next thing I'm going to do is I'm going to take my other color here. I'm going to graph these points. Let's go ahead and do 2, 2. So 2, 2. But this time, I'm going to put an open circle. Anyone tell me why I'm putting an open circle there? Underneath this greater than symbol, it's just greater than. It's not greater than or equal to. So greater than just means an open circle. Greater than or less than or equal to means closed circle. So it's okay for me on the parabola to have a closed circle on this blue dot right here too, but for the red ones, I gotta have an open circle. All right? Then we're going 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Keep on going, the party never ends. So we got this like weird half parabola hybrid line thing going on. That's what a piecewise function is. It's some weird funky looking thing that we're putting 2 things together. Now we don't have open circles on everything. Our only open circle is here at 2, 2. I'm going to stop there and answer any type of crazy questions we got. Yes, ma'am.
Why do we graph 2, 2?
Why do we graph 2, 2? Because it just kind of gives a starting point. So we can graph 2.1. We can graph 2.2. Anything bigger than 2, we just can't graph 2, 2 exactly. So that's why I put an open circle there.
Okay.
Yes, sir.
So that is still kind of the chart we have like this, we have to
We did the open circle because this is a greater than symbol and not a greater than or equal to. The little equal to part means equal to, like solid line. Just this is open circle. All right? Any other questions? Okay. Let's go ahead and do the domain and range for this. It'll go quickly, I promise. I'll go back actually so we can see the picture still. My domain and interval notation. So, do I ever have a like smallest value to the left? No. So that's negative infinity. What about going to the right? Do I ever stop going to the right? I do. At 2, good, but I have a filled-in circle at 2, 4, so filled-in circle for that x value, sticks up for that, takes up for that, replaces it, whatever. So I'm okay there. What about the arrow? Does that ever stop? No, so it keeps on going forever. So my domain is all real numbers for both of them, and interval notation, negative infinity to positive. What about my range? Is it the same thing, all real numbers? Negative infinity to positive infinity? Now what's the smallest value? 0 to infinity. 0 to infinity. And I need a parentheses at the end there. Set notation. This is the funky brackets. Set of all x such that, and when we have negative infinity to positive infinity, we like to say that x is that element of all real numbers. Or is a set of all real numbers. Another way to say that in some. For our range, set of all y's such that we can do 0 is less than or equal to y less than or equal to infinity, or we can just say y is greater than or equal to 0. So the last thing on this tells us to find when x is 3, what is y? So let's look at our picture here. When x is 3, what is my y value? 3. What about when x is negative 1? What's my y value? 1. What else we got on there since mine's cut off? Okay, this time it says when y is 4. So that's what f of x. So f of x equals 4. What's my x value? Okay, so I got 2 for my x value and negative 2. Well done. So negative 2 and positive 2. And then my last one is what? F of x equals 5? Should only be 1 to that. So when my y is 5, my x is 5. How are we doing? 1 to 10. Give me a number. 7, 1, 4, 3. What else? 0. 5.5. Cool. All right, so we're kind of getting there. 7.36. Cool. All right, let's do another one. Where am I starting? Where's my breaking point for this graph? Where does one start and one end and all that stuff? At negative 1, right? So I'm going to be graphing everything smaller than or equal to negative 1 for f of x equals 2x plus 1. And then my other one is going to be everything bigger than negative 1, so I'm going to go ahead and do negative 1. I'm going to include it, but that's my breaking point right there. That's where things are going to get weird on my picture. All right, to save some time, let's go ahead and put in 2x plus 1 into our y equals, and let's get all the x values less than 1. So on our graph, our y equals, clear that, and with 2x plus 1, get an awesome little picture. And now I'm going to press second graph to look at my table. There we go. So I would like to use everything from negative 6 to 1. So I'm going to go up here so I get to my negatives. Sorry, negative 6 to negative 1, my bad. Whoa, calm down. So it's going to be negative 11. What else we got? Negative 9, negative 7, negative 5, negative 3, negative, sorry, 1. Alright. How about x squared minus 4? Can I do the same thing? Yeah, absolutely. So let's go back to our calculator here, figure out our y equals. And it's x squared minus 4. So it's x squared minus 4. Second, you don't have to graph, you can go second table, right there. And then I'm going everything bigger than negative 1. I'm going to go ahead and include negative 1 on the picture. So my first point is negative 1 comma negative 3. What else we got? 0, 5, 12, and something really large. 21. Alright, so my first color, I'm going to graph 2x plus 1, so negative 6, comma negative 11. So way down here, kind of off the grid. Negative 5, negative 9, I think that's our first one. And it's just going up by 2 each time, the line. Okay, so at negative 1 here, did I draw my graph correctly? Should I have an open circle or a closed circle there? Okay, the three of you that said closed, why? Yes, it can be equal to. There's just the equal sign there. All right? Questions before I move on? Okay, my other color, I'm going to graph negative 1, negative 3 first. So negative 1, negative 3. Now, is this an open or a closed circle? Open. And then I'm graphing my other ones. So 0, negative 4, 1, negative 3, 2, 0, 3, 5, 2. If you want to, the alternative to doing it this way, this method, is that we graph both lines, I guess, yeah, both lines or one line, one quadratic, and erase part of the part we don't need. So if you wanted, you could graph the entire line, erase everything bigger than negative 1, graph the whole parabola, erase everything less than negative 1 that we didn't need. That's another way to do it. If that works better for you, go for it. I just know we don't necessarily have a pencil on hand, so that may be a little difficult to do. Okay, let's go over the domain and range. We'll go over this kind of quick. So my domain, is it all real numbers? Is it negative infinity, positive infinity? So it is. All right, what about my range? Sir. We're fine. Okay, so this is like one picture now. So yeah, we're finding it for the entire thing. Yeah. So the only thing that may make you worry here is this open circle. But remember, this closing circle kind of sticks up for it at that x value. What about my range? It's the same. And I guess this is supposed to be interval notation here, and then set notation is supposed to be here. Something funky happened with the typing of that. Okay, what about my set notation? How does that always start? Monkey brackets. Sub all x such that. And then what we did for the last one that was all real numbers. X is an element of all real numbers. The range, same thing, right? Set of all what this time? Y, since that Y is an element of all numbers. All right. When x is 3, what's y? X is 3, y is 5. When x is negative 1, what is y? Negative 1. It's wherever the closed circle is. I know we have 2 of them here, but it's wherever the closed circle is. So in this case, it's negative 1. What about when y is 0? When y is 0, what is x? Yeah, we got some difference. So when y is 0, what's that? 2. And lastly, when y is negative 1, we got maybe a couple answers here. Or just one, really? Yeah, negative 1. And then we could probably talk about maybe this value, wherever that is. It's not exact, but we could say maybe it's around 2, you know, 2 then 0. So we won't say specifically where that one is. How are we doing? That good? All right. Got another definition there, step function. a piecewise function that is constant over each interval in its domain. Y'all are doing great, I promise. Doing awesome. Okay, this is called a step function for a reason. It looks like a staircase. So I got a little picture of a staircase of it. What our picture is going to look like, I'm going to do a rough sketch, don't draw this, it's going to look something like that. You've seen that before when doing domain and range. Alright, so it says for everything smaller than -3. So what's smaller than -3? -4, -5, all that stuff. So I'm going to write it right here. X is less than -3. All my y values are going to be 2. So everything smaller than -3, all my y's are going to be 2. Let's go ahead and graph that. So on my picture here, I'm finding -3. My y value is a 2. Right there. Open or close circle at -3. Open. And then which way is smaller than -3? To my left or to the right? To the left. And it just keeps on going, right? O'Shea. O'Shea. Okay. What about from between -3 and 6? So can't squeeze that in. But from -3 to 6, all my y values, I'll pick a different color here, sorry, are 5. Starting at -3, do I have an open or a closed circle there? Now I got a closed, right, because it's less than or equal to. So now I'm going up to 5. Put a closed circle, and all the way to 6. Open or closed circle at 6, 5. Open, good job. And last thing, for everything bigger than 6, I don't know where that can go, like greater than 6, all my y values are going to be 8. Closed circle here. We're going off to the rest. Okay, that was weird. Any questions on that? Nothing at all? Okay. What's our domain? All real numbers. Interval notation, negative infinity to positive infinity. Range? Kind of a mean question. We can't do interval notation for this. Remember, interval is saying from this number to this number and everything in between. We only have 3 y values, right? We got 1, we got 2, and we got 3. So we have to list them in set notation. So for range, for interval, we can't do. So I'm just going to cross that out. Okay, for our domain for set notation, that's the set of all x, such that x is an element of all real numbers. We've done that, what, 4 times now? 5 times now? Our range is going to be a set of all y, such that, and then here's where we're just going to list the 3 y values. So we're going to say y equals, and then what does our y equal? 2, 5, and 8. Y'all are doing really well. All right, when f of x is 5, so that means y, right? When y is 5, what is x? All the way from -3 to 6, right? So I'm going to say from -3 all the way to 6. I'm going to list any other numbers in there you can. Great question. Why is it bracket on one, parentheses on the other? Because it's a filled-in circle and an open circle. Same thing. Since it's less than or equal to, right here, that means a bracket. Just a less than means parentheses. Yes, ma'am.
Wait, where did you get the X value?
Right here. Sorry,
Okay.
on that one.
Yeah.
Okay.
Like almost -3. It's a Y.
So the Y's are there. The X's are
Oh,
there.
okay.
Okay, next 3, what's our Y? 5. Almost there. I know, it's so much. Almost there. You want to skip 4?
Yeah.
It's just another step function. You can do that when you're like lonely bored at night or whatever. Let's do number 5 and we'll finish with that. It's beast. Beast and a half. Okay. If you want to use the calculator, that's cool. We're plugging in numbers. So my first break is at -3. So I'm going to go from -3 all the way to -6, or anything less than -3 to be honest. Then I'm going from -3 to 1. And then I'm going everything bigger than 1. Okay, 3x plus 8. Plug those numbers in right there. So you can do that in the calculator if you want, or if you just want to plug them in. Either way, I'll give you that 10 seconds to choose. Okay, what's my first order pair? -6 comma -10. My next one is what? -7? -4, -1. All right, my middle section. Now I'm going to this function. My first order pair is -3 comma 6. 4, 2, 0, and -2. And my last one, I'm just plugging these x values in out of this third column. So 1, -2, 2, comma 1, 6, and 13. Now 3-parter. Who is excited? I'm excited. -6, comma -10. Down here. -5, -7. -4. All right, do I do any open or close on any of that? I hear some whispers. Why open and where? It's just less than, so where should that open circle go? Here at the end or up here? Up here, right? Alright, that's my first one. I did that in red here. Keeping track at home. I'll do in blue. Okay, -3, 6. I jumped way up here. 1, 2, 3, 4, it. Do I have any open circles on that one at all? And if you're wondering how I'm asking this question, we look back at our equation up here. We see what symbols we have. Do we have less than or less than or equal to? We have less than. We have them on both, actually. So that means open circle, open circle. Last one here in green. 1, -2. Okay, this time I got 1, -2, and it's the same point. That's okay. This time I have a greater than or equal to, so I'm going to put a built-in circle there. 2, 1. 3, 6. Way up there. Whew. Crushed it. Okay, domain is going to be from -infinity to where on our graph do we have two open circles that overlap? At -3. So -infinity to -3, union, -3 to infinity. And our range, we have open circles, but we have filled-in circles for everything else. So our range is all real numbers, sorry. So -infinity to positive infinity. And for the sake of time, I'm going to stop there.